Okay, now we're looking at a continuation of the problem that we were doing. So this is building upon the previous calculations that we did here in exam 3. Calculate the equivalent percent by mass of the sodium hydroxide. So we want to basically change from this concentration now that we know to be correct based on its we trust this number more because we standardized it, right? So here you're going to use the density. There's a solution density that was given as 1.08 grams per milliliter, and that can be determined pretty simply, right, with just a device that measures volume and a device that measures mass, and not even to a great degree of precision. I mean, that's only 2 decimal places, so you could get that from, you know, a good graduated cylinder and a good triple beam balance. So here all you're doing is you're going 3.21 moles of NaOH. I'm going to go ahead and use milliliters, so I'm going to say per 1,000 milliliters of solution, like that. And I see that I can use the density, but I need grams, right? Because I need mass over mass. So first of all, let's figure out if it's 3.21 moles per liter, how many grams per liter is that? And I'm going to do the same thing I did in the problem before, that 1 mole of NaOH was 39.997 grams of NaOH. And now I have my top number for my percent by mass. Remember, it's mass of solute on top and then mass of the whole solution on the bottom. Well, if I have 1,000 milliliters of solution and 1 milliliter of solution weighs 1.08 grams, then that mass could be determined very easily. So 1 milliliter of solution now will go up here, cancel out that, and then the 1.08 grams of solution goes on the bottom. So then I have grams of sodium hydroxide per gram of solution on the bottom. And I'm ready to just multiply straight across and divide by what's on the bottom. So pull up my calculatron, starting with the 3.21 times the 39.997 divided by 1,000 divided by 1.08. I get that. Then all this part here, since it says percent by mass, so I have mass over mass. To get percent, I get that number times 100, which I need to round into 3 sig figs, so approximately equal to 11.9% by mass NaOH. So remember earlier we thought it was going to be 12.5%. Actually, it was 11.9% by mass. A little less than what we thought, again, because sodium hydroxide being hygroscopic and water molecules, that means they attach to it. And if you've ever weighed it out yourself, you'll probably notice it kind of looks like it's wet or slick looking, like it's got water on it, and that's because it actually does. And so some chemicals do that; they attract a lot of water to them. So, that's your actual equivalent to 3.21 molar at that temperature, which caused it to be that density. Then, this is what you would actually report, be a more reportable concentration if you use the unit of percent by mass.